And there is a historic test, you must be aware of Blaine's separators, is it not? This is a typical MIP, mercury intrusion porosimeter. We have different types of port, low pressure port and high pressure port. More than anything, these tests require a lot of patience, and these are extremely expensive tests and setups. This is a helium gas pycnometer, where you have containers in which you can keep the sample and you can keep them in the control system. You can allow their interaction with helium gas, you can find out what is the volume of helium that gets displaced, and you can compute the bulk density and surface area. The balls which you are seeing over here are the standard materials which are used to calibrate the setup. This is the Blaine's air permeability apparatus, you must have used it. This is a U tube, and in the U tube, one part of the U tube is connected to a pump, hand pump, like the blood pressure machine, and this is the sample holder. So, a known weight of the sample is compacted in the sample holder, and this is attached to the Blaine's permeability apparatus. And what you are seeing over here is the mercury column. So, initially the mercury is balanced. What you have to find out is that you have to find out how much time a material takes for allowance of a certain amount of air through it, and that is why we call this setup as Blaine's air permeability apparatus. So, truly speaking, the amount of air which passes easily or not easily is converted into a specific surface area. So, no need to remember all these equations and formula, because they are all given in ASTM codes. We just try to understand what it is. So, if I create a sample at a given void ratio, and ES is the void ratio of the specific material which is being used as the standard material, ES is the standard material, which is normally cement, PPC or OPC. T is the time which is taken by manometer to drop when the sample is used, and TS is the time which is the time taken by the standard sample to drop certain amount of air through it. Specific surface area of cement is known. Again, the question is how would you get it? So, you can use different techniques to find it out. The void ratio of the sample can be obtained, and void ratio of the cement is known, and manometric drop for the cement is known, and hence you can compute the specific surface area. Earlier, people who are working in the field of cement and concrete technology, they used to use these devices. But now the question in your mind must be that where geotechnical engineers are going to use these concepts. You must have got a hint that present day practice of environmental geomechanics is how fine a material can be crushed, alright, including the fine material itself. So, imagine if I want to pulverize clays, and if I want to create nano sized particles out of it. So, this is a very different scale of the particle size on which you are traversing, because of the added advantages. When the particle becomes extremely small in size, its surface area increases, activity increases, and so on. So, these things become excellent environmental filters, sieves, and I can use them for cleaning up of different types of flue gases or the sludges. So, this is where the profession is heading to. So, I might like to use this material in the soils to decontaminate them. Are you realizing? So, when you read the papers, you will find a lot of research is being done, and this is the need of the hour.
When you go from micro to nano scale, as far as I know, like whatever understanding we have at the micro scale totally changes to at the nano scale. That nanochemistry comes in. So for that, if we are grinding it that fine, then we need to understand how we'll behave at, because there will be difference in behavior at the micro scale and nano scale.
Correct. That's right. Your observation and statement is absolutely correct, and this is a challenge which people are facing. So, bentonite, most of the bentonites can be activated for extra sensitive environmental projects. If I have to stop the leakage of, let us say, radioactivity, then I have to make material so fine, so active that nothing passes out of the voids of the soils, or for that matter even the concrete. All this is being used. You come from a place very close to that. Indian Army does all these things. Now you should explore. Thermal resistant, blast resistant, and impact resistant structures. This is what now India is doing. A lot of geotechnics is involved. Another interesting device where you can check the thermal stability of the geomaterials. Because most of the application which we have been talking about is materials coming in contact with elevated temperatures. So, how would you make refractories? How would you make bricks? How would you make tiles? How would you make different types of what you call them as refractory materials? Have you ever seen a refractory material in ovens? Normally they create a layer of clay and which acts as a very good insulator, but without that layer you can't bake the chapatis or whatever tandoors. So that's a refractory material. So when you go to the commercial level, industrial level, there they cannot do clays only, then they have to use refractories, and these refractories have to be tested for their thermal stability, particularly the minerals which you are going to use for making these things. So you will be surprised to know that geotechnical engineers help even tile industry. So some of my projects which I did for different famous tile companies were quite educative. From there only I learned what minerals to be used to create a sort of a tile. So in this system, a quick review for you. What we do is we do control heating of the sample in different environments, and this environment could be, let us say, oxygen, or it could be nitrogen. So normally the heating of the sample is done in two different types of environments, which is one is where you have free supply of oxygen, so that all the material which has to get oxygenated, oxidized, gets so. Second is in the nitrogen, so that nothing gets oxidized. And then what you observe over here is that there is a balance, micro balance attached to the sample, where you can measure up to third decimal place of the milligrams also, and you can plot a relationship like this, which shows on y axis the weight loss percentage and on the x axis the temperature. So let us first decipher the graph on y axis on the left hand side and the temperature on the x axis. This is what is known as thermogravimetric analysis, TGA. If you consider only the first two parts of the graph, this one and this one, what it shows is as the temperature increases, this side temperature increases, x axis, percentage weight loss increases. Alright. So I want to see how much a material can get rid of the moisture which is adhering on its surface, number one. Number two, what are chemical reactions which might be happening in the system when I heat it slowly. So for that there is another equipment which is known as DTA, differential thermal analysis, which is done. So this is thermogravimetric analysis and differential thermal analysis. So as the temperature increases, and increase in temperature is controlled, that means the rate of enhancement of temperature can be fixed, alright, by heating at certain temperature. So depending upon the response which you get, I can define a reaction as exothermic or endothermic reaction. So there are few soils or few minerals, when you heat them, they might become unstable. They may start showing you exothermic reactions, particularly when they come in contact with water. So when you are designing different types of systems of importance, there you have to do all these tests. Alright. So just to remind you, what we do is we do these type of testing in dry air and in inert atmosphere like nitrogen, so that we can compare the results and we can interpret the presence of different type of volatile materials in the geomaterials. So suppose I want to differentiate between different type of coals, this is a very good method. See, our subject has become mostly consulting oriented, like where you help people. So you have to apply your gray matter in solving someone's problem. So I am sure you must realize this is becoming more of diagnostics. diagnostics of the problem, diagnostic of a material, application of a material for solving a situation or a problem. This is modern day geotechnical engineering is. So, if you look at this trend, this is what is known as differential scanning calorimetry. This is another interesting tool which is used, and when you meet my students like Bini and all these people who are talking about the phase changes which are occurring in the materials during, how much heat goes in the system, how much heat comes out of the system, multi-phase geomechanics when you talk about. These type of studies become very important. Again, it shows the instability of the system. So, if you look at this graph for DSC analysis, differential scanning calorimetry, which is being used by chemical engineers quite a lot. At a given temperature, how much heat flow occurs in the material or outside the material, if I want to see this. You will observe that this material behaves very dubious, at a very small, just extreme left to the given temperature the behavior is different, and on the extreme right the behavior is different. It has two extreme peaks. These type of materials I do not want in my team, is it not? They may be very dangerous, extremely moody materials. So, I have two observations. I have two ways to eliminate these type of material. Either I do not select them, or if I select them, then I have to make sure that these materials will always remain exposed to a certain temperature range, because here also you will see that there is a thermal instability. So, a lot of engineering has to be done with the material. That is what the science of technology of the clay minerals is. Simple example is when you use different type of face packs on your face, you realize very freshness. Why? Because these are the minerals, when you put them in water and when they are adhered on the face, they produce exothermic reaction or endothermic reaction. If the mineral produces exothermic reaction, you will be very uncomfortable. So, the minerals which are used for most of the cosmetics are the ones which give you endothermic reactions. They cool your body. Most of the talc powders, they are of that type. So, this is how you can differentiate between them. The same thing is valid if I am designing a barrier system inside the ground by using a mineral, and if water or contaminant comes in contact with the mineral and lot of heat gets generated, what will happen? The whole soil might get cracked, thermally cracked. It is not a good situation. So, compatibility of the material has to be checked before you use this material for any application, thermal compatibility. So, now let me start the chemical characterization of geomaterials.
To analyze the thermal properties of different particle in the field, how it react to different temperatures.
Yeah, see, philosophically only concrete technologists talk about heat of hydration. Clear? Truly speaking, we should also be talking about heat of hydration, because chemically cement and soils are same. If you look at the composition is same. Only thing is the presence of certain chemicals is more in cement as compared to the soils. So, when this type of questions come in mind, that suppose if I have to evaluate 2-3 materials and if I have to chalk out a strategy that where what type of material should be utilized, and this is where we talk about the chemical characterization of geomaterials. This is an intricate subject. So, earlier we talked about XRD, if you remember, X-ray diffraction. Now, I am talking about X-ray fluorescence, XRF. So, XRF technique gives you the chemical composition of the material. It could be elemental analysis and the percentage oxides which are present in the material, XRF we call it. This is the unit which is used for finding out the chemical composition of geomaterials, rocks and sands and soils, different type of admixtures, so on, man-made geomaterials, natural materials, so on. In environmental geomechanics, we utilize extensively ICP, what is known as inductively coupled plasma. You must have studied in your 10+2 chemistry, I am sure. So, what ICP units are? they are used for determining the level of contamination of chemicals present in the solution of any geomaterial. So, you take geomaterial, dissolve it in water, make a solution, let the chemicals or heavy metals which are present in the system leach out in the solution, and then you analyze the solution to get the concentration of heavy metals which are present. So, there are two versions of this testing. One is only ICP, where you just do qualitative analysis, what are the heavy metals present. There is something known as MS, mass spectroscopy. So, mass spectroscopy also tells you the quantity, is quantitative analysis. pH is a very important factor as far as the chemical characterization is concerned, and I am sure all of you must have used electrodes which I will show you subsequently to determine the pH of the soils or geomaterials. In present day environmental geomechanics, we use gas chromatography. You must have come across this term, GCMS. In your environmental sciences courses, I am sure you must have used this. So, when the soils are contaminated with organic contaminants, different types of I would say gases or contaminants which are organic in nature, hydrocarbons, oil contaminated soils, different type of organic contaminants, contaminated soils, and so on. In present day industrial application, this type of analysis is becoming very important. So, we get lot of projects from the industries where they have to comply with environmental impact analysis, EIA. So, for conducting EIA, these are the tools, and then you have to do a very comprehensive analysis to show that the soils are not containing any contaminants, and hence environmental impact of the process which the industry is following is all right. Otherwise, you can submit a report to the agencies which are responsible for monitoring the environment, and they may serve a notice to close it down. So, this is becoming a very interesting profession and very intriguing. We use sometimes NMR also, nuclear magnetic resonance. You must have studied in your early physics course. This also tells you the type of bonds which are present between the soils and the contaminants, and the type of contaminants which you have, they can be obtained with the help of NMR. There is something known as FTIR spectroscopy. This is Fourier transform infrared spectroscopy, FTIR. So, these gadgets are very advanced gadgets, and they are utilized mostly to establish the bonding which is occurring between the geomaterials and the contaminants. All right. So, the very sensitive issues when we talk about the environmental norms, we can establish with the help of these gadgets. One of the tests which is done to establish the chemical characterization or the potential of the geomaterials, whether they are chemically active or not, would be cation exchange capacity, CEC. I will be talking about this. It is a simple test, and it tells you quite with accuracy what is the potential of a geomaterial to interact with the environment, how reactive it would be, how active would be. All right. Pore solution analysis, how the pore solution can be extracted from the soils. And this is where I enjoy drawing an analogy between blood sampling from human body, that you can take out the pore solution, and the way you analyze blood to diagnose the disease and remediation of the disease, similar things you can do here. Once you have the pore solution of the soils and the geomaterials, you know what is ailment, why the soils are ailing, and how to treat them, how to diagnose and how to do rectification of the disease. So, these subjects are becoming very advanced, and lot of gadgets and many efforts are being made to standardize all these things.
Sir, in cation exchange capacity, what is exactly happening? Exchange.
I'll discuss about this today. Exchange of cations. So, whatever cations a material is having, how easily it can exchange with the environment. Environment is contaminants, environment is water, environment could be different type of soils, environment could be the bacteria, environment could be any other chemical. Fine. So, this shows how easily the system can alter itself to adjust with a shock, thermal shock, chemical shock, radiological shock, radioisotopes which are coming in contact with the geomaterials and so on.
Sir, in every characterization we have what methods to specify different problems or different conditions. So it is specifically for different particular things. If we have such different soil we have in different condition we have, it is specifically refined that it is particularly for the situation. It is already find something.
This question was asked by him sometime back in the second lecture, that if you are writing off all the standard characterization of the soils, what you will be doing later on. So, you remember. So, the answer is 50-60% work is already done. So, we have a new classification system which is already ready, and if you read the papers which have published there, we are establishing why something should be used, under what circumstances. So, it is becoming a big subject slowly and slowly. This answers your question. The groundwork is already done, and several characterization schemes have already been published, and they have been accepted by international fraternity. I must have done 5-6 consultancy works where chemical characterization became so important, particularly for oil companies, where a lot of spillage of oil has occurred, and then you have to prove that this much oil has gone out, number one, to the industry, number two, compensation for the villages, number three, cleanup of the soils, and proving that yes, after so much of treatment the soils will become decontaminated. It is becoming a very complicated subject, and if you do not do these type of studies, these are the cases which are pending in the court of laws. Hope you understand. Court of justice, because everybody is looking for compensation and everybody is trying to frame other person, is it not, for violating the environmental norms. Yes.
The microbes are being used to clear the oil spills. I read that Maharashtra Pollution Control Board is also.
Yeah, that's right. So, if you remember Dr. Shashank now, he was talking about how this bacteria harps on oil sands. So, if you by any chance get a chance to go and settle down in Canada, in the Nordic countries, or Russia, where you have a lot of oil fields, there what they do is, these are known as oil sands, sands which are heavily contaminated with oil. Read it on net, it is very interesting. There they inject in bacteria, and bacteria harps on the soils and the sand particles, and what it does, it detaches the bond between the hydrocarbon and the soils, and then this can be collected and you produce hydrocarbons, or the excreta of the bacteria itself can be utilized as methane. So, this type of culture is being done. It is quite interdisciplinary work.